my lovely students, a very warm welcome to all of you. I hope all my students are doing absolutely awesome. That's what the wish of your AG ma'am. And students, this session is very important, but I think I'm pretty sure that it is more of like a revision for you all, because in the chapter number 3, atoms and molecules, I have taught you so many things already, and we'll talk about valency and electronic configuration. I hope you have revised that already. So this session will be very easy and more of like a revision for you. So stay tuned, stay till the end and follow all the things I'm going to give you. So many work to do, and would love to see that in the comment section. So this is a session of structure of atom, and what are we going to discuss? I already told you. So let's begin with none other than your AG ma'am. But before starting, I must say that there might be some students who are new to this platform, and I really want to tell you that how Vedantu can be a best platform to solve all your problems. Problems like my doubts are not getting solved instantly, and I'm facing so many problems that will stuck to my mind and will keep on haunting me until the exam will come and I'll see, oof, question will come from the same topic. That will not happen anymore, because your doubts can be solved in Vedantu platform, one-on-one with your master teachers and a team of class teachers totally dedicated for the same purpose. Notes in every session, so that you won't, I won't say a word waste, but you can utilize that time better in something revision and all. You will get the notes of each and every session here, and test in every 15 days, assignments after every session, to make sure that you will do enough questions of a topic in a twisted way possible, so that in exam, if a question will come in that way, you're like, I have already done that. We have mastered those concepts. Competitive exams preparation side by side. Then ma'am, I wanted to prepare for JEE from now on. I'm very ambitious. NEET also, or Olympiad. I want to do good in those aspects also. Definitely possible. We have special foundation classes for the same, with the choice of your own schedule and the choice of your own language. This is something, a very big opportunity, because so many students were telling me before, ma'am, I'm not free at that time when the classes are going on. So now we have so many classes, and you can choose your classes accordingly, and that your language also, language should not be a barrier. So you can attend the classes in perfect English like this platform, okay, and English also, Hindi and English, if you are more comfortable with that. So definitely possible, students, all of your problems will be solved at this platform. Not to miss an opportunity. Unlimited live classes you can attend. So it's like, oh, I am having an exam after 2 days, and there are some topics that are left. So you can attend unlimited live classes. If a teacher is taking a course, you can even attend 8 to 10 classes if you have time. And you can even stuck with 2 to 3 classes. It's like, I have school and I'm not able to give that much time. It's totally up to you how to plan it, how to, solve all of the problems with the help of all the Vedantu team here. Micro courses are chapter-based courses. So to make sure that if you are, not able to revise the chapter and still facing problems, you can do it as many times as you want. Crash courses. We have midterm and final year crash courses also. Performance reports after every session, that how you did well, so that you can set the target for yourself, that I was here, I'll try to improvise, and I'll try to improve myself with best ever possible ways. And personalized attentions of all the teachers and class teachers, all packed in one solution. And that is what, there is a link in the description box pinned by Vedantu 19 channel. Go to it and find, there will be a link to buy our pro classes, buy our pro course, and this page will come. Just select your grade, 9th class, as soon as you click it. Select your board CBSE 2021, okay, and click on get subscription, and can choose from 3 models of subscription that we have. That's 1 month, 3 months and 6 months. Now, which one is best? To be very honest, all are equally best. 1 month is more of, coming and see how the things will work, and, doing some particular chapters, and, can sort it out on your own way. So if you'll apply the special code, that's AGEPRO. AG Ma'am's code is AG. This is English channel and then Pro is the course. AGE Pro will give you 20% discount on MRP because you are attending AG Ma'am's class. For 3 months, you can save 31% on MRP. To be very honest, personal choice is this course because you'll be having a plenty of time to revise, to be with all the teachers, to understand their way, methods, and to do wonderful in your final exam. March, supposedly, enough time. 6 months also, because in case this is something that we are getting to know, maybe it's a total rumors, that exam can be postponed to May, so that you'll be having plenty of time to be here and do everything possible. Right now also it's possible to revise everything and definitely can score above 90%. So for 6 months, 43% discount, and you just have to pay 1533 rupees per month. Do not miss this opportunity. And the code is very important to apply to give you discount. Whatever I told you, that's AGEPRO. Okay, do not miss it. And you can reach out to me if you need any kind of a help that I can sort it. All right, everyone. So let's explore and revise the topic of electronic configuration and valency with your AG Ma'am. And let's start. Give me a quick high five. Or this is thumbs up, this is high five. Strange? Yeah, sometime it happens. Okay, let's start it, everyone. As I told you, I'm guessing that somehow we did so many concepts already and more of like a revision. Let's define what is electronic configuration on the very first place. That's nothing but the arrangement of electrons in different energy levels in different orbits around the nucleus. This is my nucleus. Orbits are the circular path told by Bohr in Bohr's atomic theory, in Bohr's model of an atom. And you can see one more video on Hindi channel as well, where I explained all the models of the atom, how an atom must be according to different scientists. So configuration is, according to Bohr model, the best one, that how electrons are there present into these different energy levels according to the energy levels itself, that electron must be there in the very first energy level, then second and then third and so on, because first electron should be put in the minimum energy levels and then higher and then so on. That's how it should be done. And the electron's configuration of an element describes how electrons distributed in its atomic orbits. That's what I already told you. That's how they are present, and somewhat like this. Now the thing is, ma'am, how we'll get to know that how many electrons we must put in every orbit. There must be some rule behind it, and you should know that. So why to worry? Your Anubha Ma'am is here to help you out. See, this is exactly the model of the atom that we should know. And who are the scientists who told about the rule to fill the electrons in different orbit? The name of the scientist is Bohr and Bury. It's like J.B. Bury, more of like James Bond. No, yeah. Niels Bohr and J.B. Bury worked together to sort out this. He told that this is nucleus where whole of the mass is concentrated. We have proton and neutron, neutral. And your electrons are rotated in these orbits called as 1, 2, 3, 4, also called as K shell, M shell, N shell, and L shell, and so on, KLMN. Okay. And students, the last shell in which electrons will be there is called as valence shell. Do remember that, some short thing that you guys should know. This shell is called as valence shell. For this particular example I'm telling you, the last shell carrying electron in a particular atom is called as its valence shell. The very first shell before the valence shell is called as penultimate shell. Penultimate. It's U only, okay? Penultimate shell. You can also call it N-1 shell. So valence shell is also called as small n, nth shell. So the penultimate shell will be N-1 shell, and just before shell, like the one that's coming before the penultimate shell, is called as N-2 shell, is called as anti-penultimate shell. So many students were asking me about the same, so I thought to tell you, because sometimes they'll tell you to write a configuration of a particular element and to ask the question like, what will be the number of electrons in its penultimate shell or anti-penultimate shell? So I thought to tell you, and you should know that. Okay, so what are the rules behind it? The electrons must be put according to a formula, that's 2n square, where n is the number of orbit and also called as energy level index, starts from 1, 2, 3, 4 and so on. So the very first orbit means I'll put the electron in this way, 2, 1 square. The very first shell, also called as K shell, then M shell, KL, and then we have M shell, N shell, then 2, 3 square, 2, 4 square and so on. Makes sense? First shell, second shell, third shell, fourth shell and so on. So the very first shell must carry the electron 2. 2 electrons can come, as 1 square is 1 only, and 1 into 2, 2. And then M shell will be 2 square is 4 and 4 into 2, 8. 8 electrons in the M shell. 3 square is 9, 9 into 2, 18. 18 electrons in M shell. 4 square is 16, 16 into 2 is 32. So that's how electron must put into different orbit. First shell will carry 2 electrons, second 8, third 18 and 32. In a sense that first will put the electron in first shell. When it will be completed, we'll move to second shell. When second shell will be completed with all the number of electrons, we'll move to third shell and so on, which is very easy and you should know that. And please remember this, that except first shell, it's called as a special rule, I'll tell you, except first shell, all the shells will be stable if they will be having 8 electron in its outermost orbit. And you know that ma'am already told you outermost orbit is called as that valence shell. So this rule is called as octet rule. So they define this rule also, that except first shell. Why except first shell? Because first shell is just having a capacity of 2 electron and we can't put more than 2 electron. So for first shell there is a duplet rule. Except first shell, all of the orbit will follow octet rule. Either they are having capacity of 18, 32 whatsoever. First of all, they'll gain stability by having 8 electron in the last shell, called as octet rule. And just to justify its octet rule, they combine with other elements so that we can judge its valency. That's the combining capacity, how an element is going to combine with other atoms. That combines only to justify and to complete its octet. Right? Makes sense? So this is it. And I already told you that electrons fulfillment will be there according to a stepwise manner, that we'll put electron in the innermost shell, then the next and then next and so on. Okay, so let's talk about the configuration of different elements in front of you. Let's take a case. I'm taking here sodium. The very first thing that you should know while writing a configuration is the atomic number. And atomic number of sodium is 11. What atomic number is representing you, everyone? Atomic number is called as, in short, we also call it Z or Z, whatever you want to like it. I mean, whatever you want to write it. So this Z or Z is telling you number of protons. Number of protons is also atomic number, because number of protons is a unique property of every element. For every element, there is a fixed number of protons that can never change. Okay, and if proton number is 11, electron will be 11 too. The reason is atom is neutral and the number of positive charge must always be equal to number of negative charge. So 11 means 11 proton and 11 electron. And how I will write 11 electron in different orbit? Suppose I'm writing K shell, L shell, M shell and so on. So how you will write it? First shell is having a capacity of 2. So first we'll put 2 in the first shell. Next is having a capacity of 8. So I'll put 8 electron in the next shell. I'm left with only 1 electron, as total are 11. So this is 1 shell in the M orbit. Okay. This is also a way to write the electronic configuration. This is like representing it with the help of a diagram. Okay. It's like differentiating it by representing an electronic arrangement in the atom. Atomic diagram to represent it. And you can see that your valence shell here is carrying 1 electron. Yeah, totally okay with you, because I'm focusing on valence shell because of some reasons, and you'll get it very soon. Let's talk about all the elements given, but for you guys, the important one is still 20. 20 atomic number, how to write configuration, you must know. Let's take the case of lithium-2 having a configuration of 3. We have 3 proton and 3 electron as said. First is having a capacity of 2, second is having a capacity of 8, but we are just having 1. So can you see, you can write it in this way. First shell carrying 2 electron, next shell carrying 1 electron. Did you see lithium and sodium both had 1 electron in the last shell. If I talk about potassium, 19 atomic number, first shell 2 capacity, second 8 capacity, third 18. But as I told you, for them, look it as a special case, a star mark. Their octet must be completed. So as soon as you put 8 electron, and they are having a special requirement, that's why I marked a star, that when you start filling electron in the third shell, please remember this fact that you can put 2 electron in the next shell, because up to 2 electron they can be moved to next shell, because this shell will say that I am achieving stability by putting 8 electrons. Now if up to 2 electron I can manage, you can put into the next shell, and then if there is no choice, then after 2 electrons can come back and can be filled into my orbit. So here 2, 8, 8, 18, 1 electron is left that can be put into this next shell. Strange case, but that's totally true. The exact reason you will get to know in 11th class when the concept of orbitals will come to you. That we have SPDF kind of orbitals, and their energy also matters, how to fill electrons in these orbitals. Okay, not going to discuss right now. Please make it a note that while putting electrons in the third shell, though it's having a capacity of 18 electron, after putting 8 electron, we have a special choice that 2 more electron, if will be there, can be put into the fourth shell. Up to 2 electron, that's it. Okay. Now let's discuss one more case. Chlorine's configuration will be what? Atomic number is 17. Configuration is 2, 8 and 7. I hope it makes sense right now. 2 electron in the first orbit, second 8, and next will be 7. Valence shell is having 7 electron. Makes sense? So they can ask to write any of the configuration either in form of atomic models or in the form of just representing electron in KL, MN shell, that's it. Argon, a very special kind of a case, having an atomic number 18, and you can represent its configuration like this, 288. And the best part is what? The last shell is already following octet rule, and just because of this, that will not combine with any of the element because it's already following its octet. That's why this substance is called as a noble gas, an inert gas also, because that's inert in nature, that is not going to react, non-reactive. They're not going to react because it's already stable in nature. Yeah, very amazing thing, but that's definitely true. And I am pretty sure that you can work it out now. So your work is a bit more, but I would love to see. There are all the first 20 elements in front of you, how you can put electron in all the 20 elements. Knowing the fact, I drew basic diagram that this hydrogen helium is just having 1 shell, lithium to neon 2 shell, sodium to argon 3 shell, and potassium calcium 4 shell. You just need to put electron now following the octet rule. Very, very easy. And I somehow gave the hint also. Look at this. Hydrogen 1, helium 2, lithium 2, 1, beryllium 2, 2, then 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, 2, 8. Now done, because 8 electrons are there. That's what the fulfillment of the second orbit. We will move to the third one. So 281, 282, 283, 284, 285, 286, 287, 288. And then after putting 8 electron, as ma'am said, that up to 2 electron can move to next shell. So 2881, 2882. That's it. This is your calcium having atomic number 20. And after that, you do not need to know because will not come into exam. You will get to know in what class? 11th class. So something can be left for higher classes. Okay. So there's a one question to check your knowledge, everyone. Very easy. If K and L shell of an atom are full, then what would be the total number of electrons in the atom? and you're like, ma'am, you already told the answer of the previous question, what to tell now? So I have a question for you. Do let me know in the comment section. K shell and L shell is completely filled. What would be the total number of electrons? Do let me know its name also. What will be that element? Good? Awesome. Now let's talk about valency also, and that's totally dependent on the electronic configuration that I've taught you. See, I was using this term again and again, if you remember. Valence electron, the number of electron present in the last shell, outermost shell of an atom. And why valence electron is important? That decides how an element is going to combine with the other element so that its octet will be completed. So just to complete its octet, it will lose electron, it will gain electron, and it can share electron so that somehow its last shell can carry 8 electron, except the first shell. Always remember, the very first shell always carrying or always follow a duplet rule, 2 electron rule, because it doesn't have any more choice. Okay, students? So Bohr and Bury saw that and already told you that the maximum of 18 electrons can be there in the last shell. No denying in the fact, because ma'am already told you, and that's how we'll define valency. That's the combining capacity of the atom to other elements, to the other atoms, how an atom is going to combine with other atom. Why for the first place? Just to complete its octet. And just to complete its octet, how they are going to combine? Either one will lose electron, other will accept it, or the both will be like, we are kind of a same family and we'll share electrons to each other. That defines the valency. The one way to define valency, the combining capacity of an element. Second way, to follow a stable configuration, an atom lose, gain or share electron, and this is known as its valency, the number of electrons lost, gain or shared. Okay. So let's talk about that. How we'll define the valency. I mean, how we'll get to know about the valency. Let's do that. Let's do that. Okay, I'll help you with some of the very kind of a tricks that I'm going to tell you. This is a trick, okay? Always remember. 3 tricks I'm telling you. Metals, how to check whether a given substance is metal. Metal's last shell, called as valence shell, must be carrying either 1, 2 or 3 electron. That's true. If a substance is metal, in the last shell, valence shell, there will be either 1, 2 or 3 electron, because up to 3 electrons it's easy to lose. Easy to lose. And as ma'am told you, whatever will be the number of electron lost, that's its valency. So for metals, if the valence electron is 1, 2, 3, what will be the valency? Valency will be 1 or 2 or 3, depending upon whatever will be the number of electron lost. Done? Sorted? Let's talk about non-metals on the same place. If I talk about non-metals, everyone, in general, non-metals last shell, called as valence shell, is carrying either 5, 6 or 7 valence electron. Ma'am, why not 8? 8 is already fulfilled. Octet rule is following. That won't react at all. Okay, noble gas, inert gas, that will be 5, 6, 7. And they have a capacity to gain electron. The reason is, just to lose 5 electron to stabilize the atom is not a good deal. Just to lose 6 or to 7 electron, not a good deal energetically. Tremendous amount of energy is required for the same. But on the other hand, 5 will try to gain 3, because by gaining 3, its octet will be completed. By gaining 2, 6 valence electron will become 8, octet completed. By gaining 1, 7 valence electron now will be 8, octet is completed. So it's easy to gain 1 to 3 electron. And on the same hand, previously I told you, it's easy to lose 1 to 3 electron. So when you have non-metals, last shell is going to carry 5, 6, 7 electron, and valency will be 8 minus valence electron, or just see that. You can guess that. 5 valence electron, valency will be 3. The number of electron gained. Valency is either number of electron lost or number of electron gained. Third case I'll discuss. So 3 electron will be gained, valency 3. 2 electron will be gained, valency 2. 1 electron will be gained, valency 1. And you can simply follow this formula too. That is 8 minus valence electron. 8 minus 5, 8 minus 6, 8 minus 7. That will give you the same. 3, 2, 1. Correct? Okay, and you can take a screenshot, you can make bullet points because it will help you. You can download the session notes also. It will be available within 2 to 3 hours of the session, because it takes time for the team to upload and put it over there. One more case, ma'am, you didn't tell what happened when the valence electron is 4. Students in general, those are non-metals only. We have some exception, but it's okay if you don't know that. Valence electron 4, if you have, that's also most of the cases that you should know is non-metal. And in the case of 4, losing 4 electron and gaining 4 electron is energetically an equal deal, and tremendous amount of energy is required for the same. To lose 4, to gain 4. It's like on that case. Earlier 1, 2, 3 or 5, 6, 7, we can say up to 3 easy to lose, up to 3 easy to gain. What about 4? Both difficult for the same. So it has this third case. It will share its electron, and how many electrons it needed to be shared. If it is having 4 electrons must be shared, because if it will share 4 electron, 4 and 4 8, and its octet will be completed. So in that case also valency will be 4. Share, number of electron lost, metal. Number of electron gained, non-metal. Number of electrons shared, third case. So I can tell you in an easy way, you can remember this line. If valence electron is less than or equal to 4, valence electron is equal to valency. Okay, if valence electron is greater than 4, valency will be 5 minus valence electron. Got it? Valence electron less than or equal to 4, it's equal to its valency also, and valence electron greater than 4, that's like 5, 6, 7, 8, valency will be valence electron minus valency will be 8 minus valence electron. Okay, I just wrote by mistake 5, 8 minus valence electron. 8 minus 5, 8 minus 6, 8 minus 7, 8 minus 8. So for noble gases, 8 minus 8 means 0. Noble gases are having a valency that's equal to 0, because they won't gain, they won't share, and they won't lose electron as well. Got it? So they have a 0 valency. They are already stable. They won't combine. And valency was the combining capacity, right? So it becomes very, very easy now to know that. If I look at hydrogen, lithium, sodium, there are some cases given. Ma'am wrote its configuration to make it easy for you. This is 281 and this is just 21. 1, 1, 1. And I told you last shell 1 electron, valency 1. Very easy. So can you tell me what's the valency of magnesium? 12 atomic number. Aluminium, 13 atomic number. Second question of the day. Didn't I tell you that ma'am is going to ask you some fair questions to you? So do let me know some of the configuration that I asked you. Do let me know the valency here of magnesium, aluminium, with all the tricks that ma'am has given, because now it becomes so easy to justify the capacity, to justify the octet rule, how many electrons an atom will gain, lose or share. If I talk about fluorine case, I can discuss one more and more practice. We say more the merrier, and it will make you like perfect is like exaggeration, but will help you to do better and better. 7, and you know that valency will be 8 minus 7, 1. It will gain 1 electron. All right. And what about oxygen? Configuration is 8, 2, 6. More than 4 electron, valency will be 8 minus 6, 2. 2 electron it will gain to justify its octet. It's a non-metal. I told you why it's a non-metal too. Okay, so this concept of valency is super clear. What is valency? This combining capacity. Some more question. Chlorine we discussed. Sulfur and magnesium. 287, 286. Ma'am is doing it so fast. I'm not able to do it that fast because I have taught from past 5 years. Take your time, but do enough practice. Valency will be 1. Valency here 2. Valency here 2. Did you see this magic? It will be having 1 valency because it will gain 1 electron. But if I compare these two cases, I wrote both the time 2 valency. Though in one of the case there are 6 valence electron, in one of the case there are 2 valence electron. The reason is it will gain 2 electrons, so valency is 2. It will lose 2 electrons, so valency is 2. Sulfur is a non-metal, magnesium is a metal. Metal lose electron, non-metal can accept those electrons. But valency can be a fixed number too. So more of like a summary, which we already know because ma'am told you. So take a screenshot of the same too. I am no way in between the content. This is a table where every information is written. Atomic number, proton, neutron, electron, and if you know electron, it's their configuration is written, and then valency too. One table helping you the most. Done. So students, this session was very, very easy, and I hope you have mastered it with your AG ma'am. In the next session, keep following because we are going to take a Menti. I know that you're pretty excited for the same, so stay tuned. And you know, with Vedantu, it's possible that result can come from every corner of India. That's in Hindi, so I thought I translated in English. We got 548 rank across the India from the toughest exam, that's JEE Advanced. And 1 out of 3 students who cleared JEE Mains, being a Vedantu student, also cleared JEE Advanced with a wonderful rank. That's the power of this online platform, and you can totally believe in the same. We scored a very good rank in NEET too. 27 students scored above 600, 46 students above 550, and we have a very huge and good result in all the online platforms in terms of 10th and 12th scoring more than 90%. So isn't it awesome? Your picture can definitely be here because you will say that, ma'am, I can do and I will. This is more of like a hashtag of the day. Do let me know in the comment section. Yes, ma'am, I can and I will, and definitely possible for me too. For the same, you can take Vedantu Master Scholarship Admission Test that is happening from 25th October to 29th October, 3 p.m. every Sunday. So not taking your regular classes time from grade 6 to 13 so that you can win scholarship up to 100% also from the total that scholarship worth 100 crores. Pretty big. Okay, and you can definitely take our pro classes by selecting the link given in Vedantu 9th description box. There was a pinned message by Vedantu. Select your grade 9, select your target CBSE 2021, and then take your subscription. Choose wisely from 1, 3 and 6 months. I told you if the duration is something that will give you more and more discount. All the courses are equally best. 1 month, shorter period of time. 3 months will be, I should say, just like in general accurate time looking at for your exams. So you can save 20 to 31 to 43% if you will apply the coupon code AGEPRO. AG ma'am's code AGPRO, and avail the wonderful discount by team and be there with all the classes of Anubha Ma'am and all the teachers of Vedantu that you already know, and so many more wonderful ones by every information right here. So this is it, students, for today. I hope you have enjoyed it. Do let me know. Ma'am will wait for your response, your homework too. And keep subscribing, keep loving this channel. Make it a big hit as well because we need your support. Share it to all your friends and do not forget to subscribe it. Reach out to me on my email ID. I'll come next time with the same josh and energy. Until then, just stay subscribed and happy learning.